Hello everyone, this is Miss Williams. This is our Unit 1, Video 2 video on factoring. So we did a little bit of factoring in class today. So what we're going to do is take it a little bit step further. There are many ways to factor. One way, and we actually covered this a little bit in class, is the greatest common factor. Another one that we have not done in class yet, but you may have seen before, is difference of two squares. It's a special case where you can factor. Sum and difference of two cubes. Factoring a trinomial with a equals 1, and that's what we did last time in class. And factoring a trinomial when a does not equal 1. And finally, factor by grouping. We're not going to cover all these today, but we are going to cover some of them. Alright, so why do we even factor? So now we're making a connection to last unit, and one reason to factor polynomials is to find its roots or its zeros. And if you remember, last time we talked very briefly, but we did talk about that roots really mean where the graph crosses the x-axis or the x-intercepts. When you find the roots of the function, it can help you graph the function, and that's what we ultimately want to do, is graph higher order polynomials. Alright, so factoring with greatest common factor. Again, we did this in class the other day. X squared plus 3x. So if you look at x squared plus 3x, you can break that down into x times x and 3 times x. And then once you break it down, it's easier sometimes to see that both terms, the x squared and the 3x, have an x that I can pull out. When I pull an x out of both of those, I have an x plus 3 left. Those are your factors. So how can that help me graph? Well, I'm going to take each one of those factors and set it equal to 0, and then I'm going to solve for them. So x equals 0 and x plus 3 equals 0. These were my two factors. And when I solve these two for x, you would get two zeros. So x equals 0, because x equals 0 is already solved. And then to get x plus 3 by itself, you would subtract 3 from both sides. Now let's take a look at the graph of the original equation, x squared plus 3x. So this is what it looks like. What do you notice? You should notice that the roots, or the zeros, are also the x-intercepts, which is 0 and negative 3, and that's where the graph crosses the x-axis. Okay. Factoring with difference of two squares. So this is a formula that you're going to need to know, that a squared minus b squared can be factored into a plus b and a minus b. It's just a little shortcut method. So here's an example problem, x squared minus 1. Well, we know that x has been squared for the first term, but sometimes people forget that 1 is a perfect square too. 1, 4, 9, 16, those are all perfect squares. Well, 1 is a perfect square. So what I really have is x that's being squared and 1 that's being squared. So I would just, x being my a, 1 being my b, I would just plug it into the formula, x plus 1, x minus 1. If you were to FOIL that out, you would end up with x squared minus 1. Okay, here's another one, x squared minus 49. So again, if you don't know your multiplication tables, it's going to be a little challenging. So 49 is a perfect square because 7 times 7 is 49. So I would just write x plus 7, x minus 7. Doesn't matter if you put the plus sign first or the minus sign first. So it gets a little harder, 16x squared minus 49y squared. Well, this is only going to work. You can only do difference of two squares if everything in your equation is a perfect square. So 16 is 4 squared. X squared is x that's been squared. 49 is 7 that's squared. And y squared is y that's been squared. So you can make it look like this. Okay, and then it's a matter of just plugging it into your formula. So it would be 4x minus 7y and 4x plus 7y. So it's important you know your difference of your square roots. The next one is sum and difference of two cubes. This is where you're cubing things. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 4. I'm sorry, 2 times 2 is 4 times 2 is 8, so 8 is a perfect cube. Okay, so these are some things you're going to need to know also. First thing I have to observe is if it is an addition or subtraction, and this is an addition one, so we have x to the third plus 8. So this is x that's been cubed and 2 that's been cubed, therefore the a is going to be my x, and the b is going to be 2. So I just plug it into that top formula up there. A plus b times a squared minus ab plus b squared. So x plus 2, x squared minus 2x plus 2 squared. But don't ever leave it as 2 squared, because we all know 2 squared is really 4. So this would be your final answer. Okay. Works the same way with subtraction. So 8 times 8 is 64, but I don't want a squared, I need a cube. So I have to think to myself, what can I cube to get 64? Well, the answer is 4. Also having to notice that it's a subtraction problem. So the only thing that changes in those two equations is your plus sign in your first parentheses and the very first addition and subtraction sign in the second parentheses. Okay, so x minus 4 times x squared plus 2x plus 16. Well, where did I get 16 from? Because 16 is nothing but 4 that has been squared, because at the end, b is squared. Okay, that's all for today. Make sure you take those notes. We'll work on some of these problems and some other factoring when you come back to class.